What's up guys? Welcome back to my YouTube channel, and for today's vlog, I will be doing the summary of chapter 2. So if you want to learn something about me and if you want to get some information about the chapter 2, so stay tuned, and I'll be back guys. Okay guys, so for the chapter 2, there is a topic of configure a network operating system. So every computer requires an operating system to function. Then including computer-based network devices such as switches, routers, access points, and firewalls. So these network devices use an operating system called a network operating system. So a network operating system enables a device hardware to function and provides an interface to users to interact. So Inter-Network Operating System, or the IOS, is a generic term for the collection of network operating system used by Cisco networking devices. So Cisco IOS is used for most Cisco devices regardless of the type or size. So again, the iOS is the Inter-Network operating system. So our operating system is all end devices and network devices require an operating system, or ODOS. The portion of the OS that interacts directly with computer hardware is known as the kernel. The portion that interfaces with applications and the users is known as the shell, and the user can interact with the shell using a command line interface, CLI, or a graphical user interface, or the GUI. So when using a CLI, or the command line interface, the users interacts directly with the systems in text-based environment by entering commands on the keyboard at a command prompt. So the system executes the command, often providing textual output. Then the CLI requires very little overhead to operate. So however, it does requires that the user have knowledge of the underlying structure that controls the system. So a GUI interface such as Windows, the OS X, the Apple iOS, then or Android allows the users to interact with the system using an environment of graphical icons, menus, and windows. So the GUI example is more user-friendly and requires less knowledge of the underlying command structure that controls the system. So for this reason, many individuals rely on GUI environment. So the operating system on home router is usually called firmware. So again, the operating system usually using in our home is the firmware. So the most common method for configuring a home router is by using a web browser based GUI. So network operating systems are similar to a PC operating system. So through a GUI, a PC operating system enables a user to, first one is use a mouse to make selections and run programs. Then the next one is enter text and text-based commands, view. And the next one is the view output on a monitor. So the first one is use a mouse to make selections and run programs. So if we use a mouse into the desktop or into the laptop, we can use that to run a program or to make these selections. Then enter text and text-based commands, then the view output on a monitor. A CLI-based network operating system like the Cisco IOS and a switch or router enables a network technician to, first one is use a keyboard to run CLI-based network program. So the second one is use a keyboard to enter text and text-based commands, and the third one is view output on a monitor. So the Cisco networking devices run particular versions of the Cisco IOS. The iOS version is dependent on the type of device being used and the required features. So while all devices come with a default iOS and feature set, it is possible to upgrade the iOS version of version or future set to obtain additional capabilities. So, basic iOS command structure. So, a Cisco iOS device supports many commands. Each iOS command has a specific format or syntax and can only be executed in the appropriate mode. So, the general syntax for a command is the command followed by an appropriate keywords, the arguments. So, the first one is the keyword. So, keyword is a specific parameter defined in the operating system. So, the argument is not predefined, a value or variable defined by the user. So, the IP address is the use of IP addresses is the primary means of enabling devices to locate one another and establish end-to-end communication on the internet. So each end device on a network must be configured with an IP address. So the structure of an IPv4 address is called dotted decimal notation and is represented by 4 decimal numbers. So between 0 and 255, the IPv4 addresses are assigned to individual devices connected to a network. So with the IPv4 address, a subnet mask is also necessary. An IPv4 subnet mask is a 32-bit value that separates the network portion of the address from the host portion. So coupled with the IPv4 address, the subnet mask determines with particular subnet the device is a member. So IP addresses can be assigned to both physical ports and virtual interfaces on devices. Then a virtual interface means that there is no physical hardware on the device associated with it. So moving on for our interfaces and ports. Network communications depend on end user devices interfaces. So networking device interfaces and the cables that connect them. Then each physical interface has specifications or standards that define each of it. So a cable connecting to the interface must be designed to match the physical standards of the interface. So type of network media include twisted pair copper cables, fiber optic cables, coaxial cables or wireless is sample of the ports. So the different types of network media have different features and benefits. So not all networks media has the same characteristic and is appropriate for the same purpose. So some of the differences between various types of media is including first one is distance. The media can successfully carry a signal. Then environment in which the media is to be installed. Then amount of data and the speed at which it must be transmitted. And the last one is cost of media and installation. So for the next topic is the manual IP address configuration for end devices. So in order for an end devices to communicate over the network, it must be configured with an unique IPv4 address and subnet mask. So IP address information can be entered into an devices manually. So or automatically using dynamic host configuration protocol or the DHCP and the automatic IP address configuration for end devices. So PCs typically default to using DHCP for automatic IPv4 address configuration. So DHCP is a technology that is used in almost every network, and the best way to understand why DHCP is so popular is by considering all the extra work that would have to take place without it. So Cisco is a term for that encompasses a number of different operating systems, so which runs on various networking devices. So the technician can enter commands to configure or program the device to perform various networking functions. So the Cisco IOS routers and switches perform functions that that network professionals depend upon to make their networks operate as expected. So the services provided by the Cisco IOS are accessed using a command line interface or the CLI, so which is accessed by either the console port, the AUX port, or the SSH or Telnet. So after connected to the CLI, network technicians can make configuration changes to Cisco IOS devices. So the Cisco IOS is designed as a modal operating system, which means a network technician must navigate through various hierarchical mode of the iOS. So each mode supports different iOS commands. So Cisco iOS routers and switches support a similar model. Operating systems support similar command structure and support many of the same commands. And in addition, both devices have identical initial configuration steps when implementing them in a network. So this chapter introduces the Cisco iOS and it details the various modes of the Cisco iOS that is and examine the basic command structure that is used to configure it. So it also walk through the initial settings of a Cisco iOS and switch device. So including setting a name, limiting access to the device configuration, then configuring banner messages and saving the configuration. And for the next chapter, we will explore how packets are moved across the network infrastructure and introduce you to the rules of packet communication. So that's all guys for this vid for the chapter 2. So I hope you get something information, or I hope you learn something from me and you get some information about the chapter 2. So I will be back guys for another vid and we will be doing the summary of the chapter. So see you guys.